This course is actually petroleum geology, but they call it exploration. Is it clear? They call it exploration or geology. Now, exploration simply means the search for hydrocarbon-bearing structures in an oil province or in an environment where the scientific information has shown that there is the likelihood of hydrocarbons. So that is, in a nutshell, what exploration is.
Sir, please give me 5 seconds. Please, Engineer Joshua, you've been muted. Please unmute yourself so that we can hear you. We cannot hear you. Please, you've been muted. Unmute yourself. Thank you.
Yeah. Yes, as I was saying, I said I'm going to share the material after some time, but I want to give you some information first because of the time that we wasted. Yeah, so I'm trying to let you know that petroleum geology, which you also call exploration, is concerned with the search for a mineral resource. And the mineral resource could be solid mineral, it could be liquid mineral, it could be semi-liquid, semi-solid, or semi-liquid mineral. But in this class, we are concerned with crude oil or natural gas exploration, which together are referred to as petroleum exploration. Is it clear? Now, I said in searching for crude oil or natural gas, what geologists do is to look for oil-bearing structures. Structures that when you find them in a place, then the likelihood of seeing crude oil or natural gas there becomes very high. Is it clear? I've also said that some of these structures include anticline, they include soft dome, they include structural traps, they include stratigraphic traps, etc. So when those geological or geographic features are found in a place, then the likelihood of discovering crude oil or natural gas in that place becomes very high. That is in a nutshell what exploration is. Now, petroleum geology, which is part of its exploration, comprises those geological disciplines which are of greatest significance for the recovery of oil and gas. I come again. Petroleum geology is not only concerns all the disciplines. Please be circumspect and understand what I'm explaining. Petroleum geology comprises those geological disciplines which are of greatest importance for finding and recovery oil and gas. What we mean by this is that petroleum geology encompasses geology as a course, geophysics, petroleum engineering, etc., even geochemistry, among other disciplines. All the disciplines need to come together to find crude oil and natural gas and to recover the crude oil and natural gas is discovered. Is it clear? That is one point. Now, petroleum geology is the study of the origin, occurrence, movement, accumulation, and exploration of hydrocarbon fuels. It refers to the specific set of geological disciplines that are applied to the search of hydrocarbons, that is oil exploration. Is that clear? It is important to understand the geological process which determine the distribution of different sedimentary rocks and their physical properties. You cannot be talking about exploration when you are not talking about without talking about sedimentary rocks. Is it clear to you? So I'm going to quickly explain all these points and still come back to what I've explained before in the class, so that for the benefit of other people that are listening from other parts of Nigeria, so that they will get what we are explaining here. So now we know sedimentary rocks are rocks that are formed from decayed organic matter. Is it clear? Organic matter means the remains of dead plants and animals that were found in the ocean bottom or in the ocean floor over geologic age. When those plants and animals die, they form layers. They form what is called sediment in form of a layer. Is it clear? On yearly basis. Then when this organic matter or materials are mixed with mud, at the ocean floor, you're going to see mud and sand and silt and skeleton and all sorts of things. Then when they are acted upon with the force of compaction, because of the layers that are going to be laid upon each of them on a yearly basis, those forces of compaction turn those organic matter to sedimentary rocks. Is it clear to you? Understand the formation of sedimentary rocks now? So that is sedimentary. So sedimentary rocks is the basis of crude oil and natural gas. So now practically all petroleum occurs in sedimentary rocks. Sedimentary geology form one of the main foundations of petroleum geology. So you also get that point before I proceed. So what I'm going to do is that I'm going to quickly explain the origin of crude oil, which I believe most of you know. Please, before I go further, let me share the material so that you people will have the material on the screen. Yeah, please be patient. I'm going to share the material so that you have it on screen. Please, let me just share the material. Yeah. Yeah, I believe everybody is still hearing me. I'm sharing the material now. So in the course of sharing this material, I'm going to be talking about the origin of crude oil or petroleum, which also includes natural gas. Most of us in petroleum class or in geology class, this is not an issue. Now, there are two theories that lead to the formation of crude oil. We have the organic theory and inorganic theory. Now, because of our time, because this class, we have just two contacts. I'm not going to bore in organic origin of crude oil. I'm only going to explain the organic theory. The organic theory of crude oil formation. Is it clear? That's what I'm going to explain.
Hey, Joshua, we lost audio. We don't have audio again. Engineer Joshua, we cannot hear you. Please unmute yourself. Unmute
Yes,
yourself,
I'm
please.
explaining the organic theory of crude oil formation. Yes. Yeah, now the organic theory of crude oil formation is the most accepted theory. Other theories like the inorganic theory, some scientists are pushing on with that vision, but it cannot be accepted because of the volume of crude oil that is found that is drilled on daily basis worldwide. The inorganic theory protagonists cannot prove it. So I'm going to explain the organic theory to you. Now, the oil and gas are formed from remains of prehistoric plants and animals. Remains of plants these remains of plants and animals have been transformed to coal and animals to oil and gas. These remains were settled into seas and accumulated at the ocean floors and buried under several kilometers of sediments. Is it clear? Then over millions of years, which is called geologic age, the layers of the organic materials were compressed under the weight of the sediment above them. Is it clear? When because they are in layers, in sediments, the weight of the materials on top of them is going to compress them, turning them to solid mass. Now, with the influence or the action of temperature and pressure on these organic materials or matter, in the absence of oxygen, change the mud, sand, silt, or sediment into rocks and organic matter into kerosene. Is it clear to you? You would have studied this before, but in petroleum geology and exploration, you must know the origin of the crude oil you are doing exploration for. So that is the reason why I'm bringing this one up. Yeah. So now, having said that, there are evidence to show that crude oil actually formed to show the organic theory, to prove the organic theory. There are many evidence to prove it. Now, one of the evidence is that petroleum oil is mostly found in sedimentary rocks rather than igneous rock, such as granite and basalt. I believe people are still listening. Evidence to prove the organic origin of petroleum. Number one is that petroleum, that is crude oil and natural gas, is mostly found in sedimentary rocks. What is it called? Igneous rock or metamorphic rock cannot hold crude oil. Is it clear? Because they are not porous, they are not permeable. So now, only sedimentary rocks such as limestone, sandstone, etc., they are the rocks that can hold crude oil because they are both porous and permeable. So now we go to point number 2. Petroleum has the ability to rotate the polarization of light, which is typical for organic matter, and it is attributed to the presence of cholesterol. You know that cholesterol is a fat, and it's only animals that can have fats. Is it clear? Then number 3 point, why crude oil, the organic that support the organic theory, is that many crude oils contain porphyrin. It's also a chemical which may come either from chlorophyll in plants or from the red blood cell in animals. Are you seeing it? So this is why the organic theory is mostly accepted. Is it clear to you? The organic theory of crude oil formation is mostly accepted because of the points I'm giving to you. That the organic theory, the basis of the organic theory of crude oil formation is that crude oil and natural gas were formed from prehistoric plants and animals. And these things that will be found in crude oil, like porphyrin, can only be found in plants and animals. Then number 4, evidence to support crude oil formation, that crude oil was formed from organic matter, is that most crude oil contain nitrogen, which is an essential element in amino acid. Please write down. Most crude oils contain nitrogen, which is an essential element in amino acid. Then number 5, evidence to support the organic theory of crude oil formation is that the chemical composition of petroleum is similar to the composition of the organic matter or materials, although there are more carbon and hydrogen and less oxygen and nitrogen in oil compared to the organic materials. Is it clear? No, now this could be attributed to the number of years it took them to be converted to crude oil and natural gas. So that is that about the organic theory of crude oil formation. Now, I'm going to briefly talk about exploration. because the thrust of this course is exploration. There are many things that I need to tell you about, but because of the short time that we have, there will be no time to talk about all of them. Is it clear to you? So what I'm going to tell you now is that yes, crude oil has become is a driver of modern technology, of modern world, modern economy all over the world. We as of today, crude oil is the driver of world economy. If you remove crude oil and natural gas from the world economy today, then the world economy is going to crash instantly. Is it clear? Though there are theories, there are other energy sources that are still other experiments that will come up in the future. That is non-fossil energy sources. But as it stands today, you cannot take petroleum from the world energy mix and say the world economy will remain the same. So for that reason, exploration is going on even as we speak. Now, what is exploration? I've explained at the beginning that exploration is the search for crude oil and natural gas. Now, exploration is done by geologists and geophysicists. Now, how is it in a nutshell? In a nutshell, what do geologists do? Geologists study oil-bearing structures that they know can hold crude oil. That is what they study. All this, and some of the structures I've already told you that they include soft dome, they include what I call stratigraphic traps, structural traps, and anticlines. That is what geologists study. So now, geology, geologists which are in charge of exploration and geophysicists, they do exploration either in the body of water or they do exploration on land. Now, the bulk of the world energy, petroleum today and natural gas can be found in the ocean bottom, ocean floor, or what is called the marine environment. Or like in the past, where the bulk of the world oil was found on land. Now, exploration on water is more diverse, is more challenging than exploration on land. Now, how is exploration done? In a nutshell, when you are doing exploration on land, you use many instruments. You use geophones as the major instrument that you're going to use. You use geophone, you use the exploration truck. Now, how is it done? Geologists will send. There are different exploration methods that can be used. You have gravimetric method, you have a magnetometric method, you have a seismic method, etc. But as it stands today, the most reliable exploration method is the seismic method. Please, you both should take note of it. The most reliable exploration method today is the seismic method of exploration. Now, in seismic method of exploration, I'm going to explain it better as this course progresses. What happened in seismic method is that signals, waves are sent to the earth crust. Are you following? Waves are sent to the earth crust at a very high speed. Now, those signals that are sent to the earth crust are recorded as the waves they are going to be meeting different geological structures, different geographical structures. Is it clear? Now, as those waves are sent down, the structures naturally, you know from waves in physics that waves, one of the properties of waves is that they can be refracted and they can also be reflected, depending on whether you are dealing with light waves or sound waves. In this case, we are dealing with sound waves. So one of the characteristics of sound waves is that they can be reflected and they can also be refracted. So the signals that are sent to the earth crust, when they hit different structures, they send back what is called refracted or reflected rays. Please let me tell you before we go further that when you are dealing with reflected rays, the technology is higher than when you are dealing with refracted rays, and it's also more expensive to carry out because reflected rays are more reliable than refracted rays in geology, in exploration. Please, I come again. Reflected rays are more reliable than refracted rays when you are doing exploration for oil and gas. Is it clear? In any environment. So now, the signal that you send to the earth crust, those signals will come back to you in form of reflected waves. Is it clear? They are going to come back to you in form of reflected waves. And when those waves come back, they are recorded by the geophones. The geophones will record all the waves or reflected waves that have been sent back. When those waves are sent back, they can be sent from the exploration zone where you are doing your exploration. You are going to be doing exploration in a remote zone, very far from town. So those information that you get through your geophone can now be sent to a remote a facility outside the remote location where you are doing your exploration. Those information that are sent, real-time information that are sent, will now be analyzed by geologists and geophysicists. Is it clear to you? They will be analyzed, then the useful ones are taken, and decision is they make decision based on those information. The decision they are going to make is that if this area has crude oil, what is the quantity? What is the volume of crude oil? What is the best method of recovering the crude oil? Or is the crude oil economical? Is it economical to exploit, to produce? Or this is nothing that they cannot produce at that time with the current economic situation? Those are the things that the geologists are going to be analyzing with their computers. Is it clear to you? So that is that. So now, geophysical exploration method, that's what we are still talking about. Geophysics, please, I've explained everything about geology. I believe by now everybody understands what we are talking about when we are talking about geology. I've talked about geology. Now I'm going to be talking about geophysics, because when I started with petroleum geology, I told you that petroleum geology encompasses different disciplines that are concerned with exploration and production. That is recovery of the crude oil. Not just exploration, they explore and analyze. Is it clear? The essence of the analysis is to determine whether the area is productive, whether the crude oil or natural gas in that environment is economical to produce. That is the analysis. So geologists, geophysics, petroleum engineering, they are all part of petroleum geology. So now I've talked about geology, which are mainly concerned with the search for crude oil and natural gas in a water environment, that is marine environment or land environment. Now, geophysics, what do they do? Geophysics is the subsurface site characterization of the geology, geological structure, groundwater contamination, and human artifacts beneath the earth surface. I come again. Geophysics is the subsurface site characterization. That is, from a seismic survey now. In seismic, the picture of the earth crust is taken. Please, let me explain seismic further. The picture of the earth crust is going to be taken just like when you take an X-ray of somebody's chest. Is it clear? You are going to be seeing the bones of the person. You are going to be seeing some of the structures in the internal part of the body. That is what geology do. Geology, they take the picture of the subsurface. When they take the picture of the subsurface, you will now know the migration path of crude oil. You will now know the accumulation structure or system of the crude oil. You see many things that will convince you that yes, there's crude oil in this place, or there's natural gas in this place. That is that. Now, when they see all those things like migration routes, they see accumulation, they see porous rocks, they see permeable rocks. That is enough clue to show that there's crude oil in a place. Now, I'm going to throw this bomb at you, that geologists have discovered that there's crude oil in a place is not enough for production companies to take their facility to the site to start drilling. I come again. That geologists and geophysicists have come up with their theories and certainty that there is crude oil or natural gas in the place is not a yardstick, or is not enough for an oil producing company like Chevron, like Mobil, or like any local company like Coando and Fort Oil to take their facilities there, to take their drilling ring to that place and start drilling. Is it clear? You only know the quantity of oil in a place. Let me come again. Geologists and geophysicists can only tell you that there's crude oil in a place. They can also tell you the quantity of crude oil in that place, but what they tell you is not a precise. Geology and geophysics is not precise science. They can tell you that they discover so amount of crude oil in a place. You can get there and you see less. Are you still following? And you can also get there and see more. So until you drill an oil well, you can never tell how much oil is in a place. So geology and geophysics are just they are just the helpers in the search for crude oil and natural gas. They are just at the forefront, not that they can give you the actual information. The actual information about crude oil happens when you start drilling. They call them exploratory well. Exploratory wells, which is also part of exploration, they are wells that are drilled to get geologic information. I come again. Exploration wells, that is the last stage of crude oil exploration. You have done your seismic, you have used your gravimetric method, you have used your magnetometric method, you have used any method you want to use that you feel is reliable, but I've told that seismic is the most reliable for now. Because in seismic, you take the picture of the earth crust, so you are seeing the oil-bearing structures, you are seeing the migration routes. But having done all those things and you have done your analysis in a world-class laboratory, that is not enough for you to know the quantity of oil in a place. Now you have to do actual drilling. The actual drilling of an oil well, which are called exploratory wells or wildcat wells, that is what gives you the actual certainty that there's oil in a place. And that is what also gives you the actual certainty of the volume of oil that is in a place. That is whether the oil is, whether the feed that have been discovered, whether the feed is a large feed, whether it's a small feed. It is when you start drilling that you will know. Is it clear? Now, the size of a feed determines the number of years the oil is going to be produced or the gas is going to be produced before the feed gets to what is called the economic limit. Is it clear? So now, I was trying to explain to you that when you do exploration, it is until you do your drilling exploratory well, you drill the first exploratory wells, which are going to be staggered in the oil field. You drill them in different places. You can drill, if the oil field is large, you can drill 10 exploratory wells. If 6 to 7 to 8 of them are producers, that is, you met large volume of crude oil in 8 or 7, then you have done what is called confirmation. That shows that that area really has crude oil. That oil field is rich. Is it clear? Meanwhile, before you start doing your exploratory well, you would have done your seismic, you would have done a lot of geological works, but that is not enough for you to carry your facilities or to start to take your dollars to a place and start drilling. I believe I made myself clear with that information I've given to you. Now, geophysics involve mapping of the physical property variation that are remotely sensed using non-invasive technologies. Is it clear to you? Now, geophysical surveying methods, that is a subtopic. Geophysical surveying methods. Now, the task of the explorationists are, please write down if I believe I'm not too fast. I'm trying to be loud so that people will be hearing. Now, I've told you different geophysical exploration methods. I've told you that we have a magnetometric method, we have a seismic method, we have gravimetric method. That one makes use of gravity, force of gravity. Why the magnetometric method makes use of the forces of gravity that are in the earth crust. Why seismic method makes use of the seismic waves that are generated when we sense signals. We cause a disturbance in the earth crust. Is it clear? It's just like what we call echo. You know echo in physics, the reflection of sound back to us. Like when you are talking in a large hall that is not that has no furniture, that have no fittings, just a large hall, you'll be hearing your echo reflection of what you are saying. Is it clear? That is what happened in a seismic survey when they send signals to the earth crust and the signals are reflected back. And when they are reflected back, they are recorded in geophones when you are doing your exploration on land. But when you are doing your exploration on water, that is the marine environment, the signal that will be sent back from the disturbance that you have caused will be recorded by hydrophones. Is it clear? Please take note of the difference between hydrophones and geophones. Geophones are used in when you are doing your survey, your exploration on land, and you use hydrophones when you are doing your exploration on a body of water. I believe that is clear to everybody. Now, back to what I was trying to explain to you here. I said geophysical surveying methods. I've explained them. Now, the task of any explorationist, that is a geologist now, somebody that is carrying out exploration. Mind you, the other people can be trained to they call it exploration crew. The exploration crew does not comprise of different disciplines. It's not only geologists. We have other disciplines that are doing the exploration. So now, their tasks, one of the tasks of the exploration crew are find source rock. I'm going to come again, and I'm going to explain the things I'm going to explain those things. These things some of you don't know the meaning of source rock, so I'm going to explain it to you. So one of the tasks of anybody that is doing exploration, either you are doing your exploration on land, or you are doing exploration in any body of water, wherever, or you are doing exploration on marshlands, that is savanna, right? What they call it? That is mangrove swamp. Anywhere you are doing your exploration, or in the desert, wherever you are doing your exploration, one of the tasks of the exploration crew, of the geologist, or the geophysics, or the petroleum engineer, one of their tasks is to find source rock. Now, source rock are the original materials from which the crude oil was formed. Please write it down, very important. Source rock is the original material from which the crude oil was formed. Is it clear to you? So when we are talking about source rock now, we are talking about things like the organic materials, materials that are rich in plants and animals, prehistoric plants and animals, like skeletons of dead plants and animals. Is it clear to you? So the skeleton of dead animals. So a source rock is a rock with abundant hydrocarbon, prone organic matter. Is it clear? So I told you that a source rock is the original organic material from which the crude oil was formed or natural gas was formed. Is it clear? So a source rock is a rock that is rich in organic matter. Is it clear? And when we say organic matter, we are talking about plants and animals. So that covers that. Now, one other task of the exploration crew, that is those people that are doing exploration for oil and gas, is they are also looking for reservoir rock. Is it clear to you? Apart from looking for a source rock, they are also looking for a reservoir rock. Is it clear to you? Now, a rock in which oil and gas accumulate is called a reservoir rock. Please, I come again. A rock in which oil and gas accumulates is called a reservoir rock, and all reservoir rocks are sedimentary rocks. It will interest you to know that all reservoir rocks are sedimentary rocks. None of them is igneous rock, none of them is metamorphic rock. All of them are sedimentary rocks. So now I'm going to define a reservoir for you. A reservoir is a body of porous and permeable rocks containing oil and gas. So it's the same thing as a reservoir rock. So a reservoir is a reservoir rock and it's a sedimentary rock. So a rock in which oil and gas accumulates. Is it clear to you? Now, one characteristic of a reservoir rock is that it must be porous and permeable. Please listen and listen well, because I'm going to give you questions based on even your exam or everything. I'm going to give you questions based on all these things. So it's good you listen and understand. I said one of the characteristics of reservoir rock is that it must be porous and permeable. Is it clear to you? Now that leads us to the definition of porosity. My students in Lagos, in some centers in Lagos, they already know these things because I've taught them exhaustively. Now write down porosity of a rock. When we say a rock is porous, is the ratio of pore space in a rock. Please write down. I'm going to take it slowly. I said every reservoir rock must be porous and permeable. So you people will now be wondering, what do we mean by a reservoir rock must be porous and permeable? So I'm now trying to explain to you, define for you what is porosity and what is permeability. So I said porosity is the ratio of pore space in a rock over the bulk volume expressed as a percentage. I come again. Porosity is the ratio of pore space in a rock over the bulk volume expressed as a percentage. Mathematically, porosity equals pore volume over bulk volume times 100% over 1. I'm going to take it again. Mathematically, porosity equals pore volume, that is P-O-R-E is pore volume over bulk volume times 100% over 1. That is porosity. Now, what do we mean by pore volume? Now, when we say, now most of you that have not gone far in this in oil and gas, they think that when we say crude oil accumulates in subsurface structures underground, that they accumulate in form of a pool of a river, that they are formed in form of a river. Crude oil is never found underground in form of a river. Is it clear to you? It's not like a pool, like a swimming pool, like an oil river underground where you will now drill a hole and start drilling. Crude oil is stored in the pores of rocks, that is like an iron sponge. You would have seen an iron sponge before. An iron sponge has holes. Is it clear to you? So, or just like a porous media, when you are dealing with, when you in biology, when you are studying diffusion and osmosis, maybe you did it in biology practical in those days when you were in secondary school. When in osmosis, they will put a reagent at the end of a material, you will see it at the other end. That is the material has pores which the fluid can pass through. Is it clear to you? That is what happened in this case. So the reservoir rock has pores. Then, apart from having pores, the whole reservoir rock is not 100% porous. So there are also solid structures in between. In between the reservoir rock, you also have solid structures that are not porous. But in those holes, pores, the crude oil is stored there. That is what is called pore volume. While the total rock body, both the areas that have holes, otherwise known as pores, and those areas that don't have holes, that are still solid, everything is referred to as bulk volume. Is it clear to you? So you should know the difference between a pore volume and a bulk volume if you are doing petroleum geology. If you are doing exploration technology, you should be able to, or engineering, you should be able to know all these things. So that is that. Now, I've explained to you the meaning, the difference between porosity, what is pore volume and bulk volume. Now, let me make it clear to you that the porosity of reservoir rocks vary. Porosity varies from reservoir rock to reservoir rock. So the porosity of limestone and the porosity of sandstone are not the same. Is it clear? So some reservoir rock can have porosity of 35%, some can have porosity of 40%, 50%, 60%, etc. But the more porous a reservoir rock is, the easier it is for the production to take place. That is the recovery of the crude oil from the reservoir rock to the surface facilities. Is it clear to you? So that is that about reservoir rock. Now, don't forget what we are talking about. One of the tasks of explorationists or the exploration crew, apart from finding the source rock and the reservoir rock, they are also looking for migration routes. Is it clear to you? Explorationists, that is geologists and geophysicists and petroleum engineers that are in charge of exploration, they are also looking for migration route. What is migration route? Migration. Now, when crude oil is formed from the source rock, let me quickly add that after crude oil has been formed at source from the source rock, that is from the organic matter, the original plants and animals, because of the weight of the overburden pressure, that is the sediment, they are laid in sediments. Now the sediment on top are going to exert pressure on the sediment that are below. In the over geologic age, and with high temperature and pressure, those materials are converted to crude oil. When they are converted to crude oil, because crude oil is a liquid, they start to migrate. There are two types of migration. We have primary migration and we have secondary migration. Is it clear to you? In primary migration, the movement is within the source rock. Is it clear to you? In primary migration, the movement of the crude oil or natural gas that is formed is just within the source rock there. Why in secondary migration, which is the most important in petroleum engineering, the material move from the source rock to the reservoir rock. Is it clear to you people? The crude oil is going to move from the source rock to the reservoir rock. There's a difference between source rock and reservoir rock. Is it clear? The reservoir rock is the rock that is going to hold the crude oil till it is covered by explorationists. So that is that. So explorationists, geologists are also looking for what? They are also looking for migration paths. That is the path which the crude oil pass from the source rock to the reservoir rock. They are also looking for them. I believe everybody is following. Yes. Now, because we still have time, another feature that geologists are looking for in exploration, mind you, I'm not going to be talking about, when I say geologists, you know that I'm also talking about geophysicists, and I'm also talking about petroleum engineers. But geologists seems to be at the forefront of exploration. They are at the forefront. What we call what they call it in this pandemic, when they are fighting for this pandemic. That is, those are the forefront, the battlefront. When we are talking about exploration, they are at the forefront. Is it clear to you? That is battle. They are the one at the battle line. So now we are talking about migration routes and or paths, and I believe people understand what I mean by migration paths. Let me explain it again because some people will be hearing this for the first time. So it will not be fair to them for me to just jump past this migration path or route. Now I'm going to explain it again second time. I said, I believe by everybody else understand what I mean by source rock. That source rock is the material from which crude oil was formed. That source rock, they are organic matters. That is the remains of plants and animals that were now mixed with silt and sand in the ocean floor. Is it clear to you? When the overbody pressure out of them, they form crude oil, and when they form crude oil, there is movement within the source rock at that point. Is it clear to you? That movement within the source rock is called primary migration. Then over time, with more weight on top of that source rock, the crude oil is going to migrate from the source rock and start looking for reservoir rocks. It will interest you to know that crude oil will continue to migrate until you see reservoir rocks. Is it clear to all my students? Crude oil or natural gas that migrate from the source rock will continue to migrate until they discover until they see a reservoir rock. What is a reservoir rock? Rocks that are porous and permeable. I believe everybody is following. Rocks that are porous and permeable are called reservoir rocks. So if crude oil does not see a reservoir rock, it will continue to migrate. That is why some people will tell you, that is why I tell my students that the point where you discover crude oil or natural gas, most time is not where the crude oil was formed. Crude oil in the Niger Delta could have been formed from anywhere and migrated over time until it was able to discover reservoir rocks at the Niger Delta. It's a probability, it's a possibility. Is it clear to you? So crude oil can form in any state in Nigeria. It can even form from outside Nigeria and migrate to Nigeria. Crude oil can form in Niger and move to, most of the crude oil they are said they discover in the Benue Trough, the Gongola Basin. Most of them will have moved from Chad and from Niger. But as soon as they see a reservoir, they are going to stay there. Are you following? So that's about migration route or path. Now, apart from the migration route or path, explorationists, that is geologists, are also looking for traps. Is it clear to you? They are also looking for traps. A trap is also a reservoir, please. A trap is also a reservoir where crude oil is housed, where it is stored. Now, there are different types of traps. Please write it down. Number one type of trap, we have structural traps. Number 2, we have stratigraphic traps. Number 3, we have combination traps. Now, if you check your geology textbooks, you are going to see all these different type of traps. How the rock is lifted. If you see it, if you check this material, the material I'm going to send to you, you will see that one part is lifted of this, the same rock, but because of earth movement, because of pressure underneath the earth, all these rocks, a lot of things happen to them. So a rock, a sandstone, the two of them are sandstones. One can be lifted while the other is still down. Is it clear to you? That constitutes a structural trap. So now when we have a combination of structural and stratigraphic traps, then we call it a combination trap. So take note of that. So I'm still going to throw more light about traps. I'm going to throw more light about it. Rock configuration that focuses oil and gas into an accumulation. Is it clear? So it's an accumulation of crude oil and natural gas. It's called a trap. Now, the last geological or geographical feature that explorationists are looking for, they are looking for seal rock. They are also looking for what is called sealing. You can call it sealing, or you can just call it a seal, or you can call it a seal rock.
Engineer Joshua, please unmute yourself. You've been muted. Please unmute yourself.
Okay.
Engineer Joshua, you can hear me. You've been muted. Please unmute yourself.
Yes, I've done the unmute. I've done it. Yes,
Right.
I don't know where I stopped before because I was muted. I don't know how long. So for that reason, I'm going to come again by telling you that geologists, what convinced them that there's crude oil or natural gas in the place when they are doing exploration is that they must see the following geographical features in that place, in that environment when they are doing their exploration. Even though they are doing seismic and other things, they must find a source rock, They must find the reservoir rock, they must find the migration paths, and they must find traps, and they must find seals. So is this seal? I don't know whether they understand the meaning of seal. I was explaining the meaning of seal before I was muted. So now I said a seal in every reservoir rock, there is always an impervious rock at the top and at the sides. Is it clear to you? Just imagine you being in a car. This impervious rock is just like you being in a car. The front of the car, you cannot jump past the front. If the car, all the doors are locked, you are inside the car. All the doors are, just consider yourself inside the car, and the doors are locked. You cannot jump past the front. You cannot jump past the sides. You cannot jump past the back. That is what a sea does in a reservoir. So they prevent the crude from going through any side. The reason why they are able to do that is because they themselves they are not porous and permeable. They are impervious. So quickly, I'm going to talk about seismic survey, because after today we have one more class. So I'm going to be talking about seismic survey that I'll be talking. Mind you, I've introduced seismic. I've talked about seismic survey, where I told you that signals are sent to the earth crust. You can send the signals with dynamite. Is it clear? With a bomb. You can send the signal by hitting hammers on the ground. You can send the signal with different methods. We are going to be seeing them as we progress. So in seismic surveying, seismic waves are created by a control source and propagated through the subsurface. I come again. I'll explain this thing, but I'm just trying to make it more understandable so that the little we do should be understood. Yes, seismic survey. In seismic survey, I've told you that the most reliable exploration tool today is seismic survey, not magnetometric method of geophysical survey, not magnetometric, not gravimetric, but seismic. So we are going to be dealing with the seismic more. So, and I was trying to explain to you that in seismic survey, seismic waves are created by a control source and propagated through the subsurface. So just imagine yourself hitting a hammer on the ground. Is it clear to you? Now, or for example, just imagine yourself, maybe there's a solid mass of iron. Hit it at one end, you will see that the waves will be propagated to the end of that iron. That metal, it will be propagated to the end. Is it clear? So that is what happens in the earth crust. When you send signals by creating a source of disturbance at the earth surface, signals will be sent down to the surface. Is it you? Yeah. So those signals can either be sent in a marine environment or in a land environment. So some waves will return to the surface. Please listen. I'm going to explain. I'll make sure I finish this one before we close. Some waves will return to the surface after refraction and reflection at geological boundaries within the subsurface. You know what we mean by geological boundaries now? Different layers of rocks in different positions. That's what I mean by geological boundaries. Now, if you are digging the ground, for example, you are doing excavation, you meet different types of soil. First of all, you are going to see black earth, black soil they call humus. Then you start seeing red. Then you start seeing different colors of soil. That is, each of them is called a boundary. So that is what we call geologic boundary. So some waves will return to the surface. Geologic boundaries within the subsurface. That is number one. Number two, instruments distributed along the surface detect the ground motion caused by these returning waves. Now I told you that you are going to plant geophones. Assuming you are doing this your survey on land, you are going to plant geophones in different positions that are going to be getting the signal that are coming from the earth surface, and they are going to be getting them and recording them. So, and hence measure the arrival time of the waves at different ranges from the source. Is it clear to you? They are going to be getting the arrival of the waves. Then number three, these travel times may be converted into depth. Is it clear to you? The time with which the wave got to the geophone can be converted to depth. Is it clear to you? How can we convert it to depth? We are going to use the formula V equals 2S over T. I come again. The formula we are going to use here is V equals 2S over T. Or you can say 2D, where D is the depth. let me use 2D because of, but S and D, if you've done equation of motion, you know that they are the same thing. So you can use D, say V equals 2D over T, where V is the velocity with which the signal was sent or arrived, D is the depth, T is the time. So when you know the time with which the signal came back to the geophone, and you know the velocity with which you send the signal to the earth crust, then you can say 2D equals VT. So D equals VT over 2. So you will need to know the depth. This crude oil accumulation, at what depth is it? So you use it to know it. So that is that about so seismic survey. There's a graph for it. It's easier the material. Now I quickly go to the 5th point before I give you an assignment, and we'll continue the lecture. The propagation velocities of seismic pulses are determined by the elastic modulus and densities of the material through which they pass. This one is very easy now. I told you that the signal you send to the earth crust is going to pass through different types of rocks. It's going to pass through sedimentary rocks, igneous rock, metamorphic rocks. It's going to pass through body of water. It's going to pass through different things before, and as it's passing through all those things, they are going to be sending different refracted and reflected rays to the surface. Then information on the compressional and shear waves velocities. There is what's called compressional and shear waves velocities. Compressional velocities is represented by VP, while shear waves are represented by VS of rock layers encountered by seismic surveys or seismic waves. Is it clear to you? So that is that. So I'm going to quickly give you your assignment because we have 4 minutes to go. So please quickly take that assignment for today. $7:20. I started by 5:40. I'm sorry, by 7. Yeah, so we all have because this class we end by 7. We have just 4 minutes to go. So I quickly give you your assignment. Now, basically, the organic crude oil formation. Please take this assignment very serious, because if you don't know the theory of crude oil formation, you cannot be doing survey, you cannot be doing exploration for crude oil. So number 1, please explain briefly the organic theory of crude oil formation. Explain briefly the organic theory of crude oil formation. Is it clear? Explain it. That's number 1. Then number 2, you are going to also explain to me. You are going to define the following. You are going to define the following geologic terms. You are going to define the following geologic terms. You are going to define organic matter in relation to crude oil formation. You are going to explain what is called a reservoir rock. We are going to explain what is called a sea rock. We are going to explain what is called a trap. You are going to also explain what is called migration routes. This is okay for you for today. Then when we come back next time, we are going to be talking about exploration methods. We are going to explain exploration methods then. So yeah, so we continue with our class as we still have time. Yeah. So now it is important. Now that is this shear force. That is the compressional and shear waves velocities of rock layers encountered by seismic surveys is important for 2 reasons. Why are they important? It is necessary for the conversion of seismic wave travel time into depth. You know, I've given you a formula where I told you that V equals 2D over T. For you to get the depth where the crude oil is, then you have to say 2D equals VT, which implies that D equals VT over 2. So we use shear wave and compressional wave or velocities to get the depth of the accumulation. Is it clear to you? Also, the shear wave and the conventional wave of velocities also provide an indication of the lithology of a rock, or in some cases, the nature of the fluid contained in it. The lithology, the type of rock, also to get rock. So while we have backgrounds, we also use technology to get a lot of information. Is it clear to you? So that is that. So that is what we can also get from there. So there are formulas and some calculations that you can get here. So that is that about seismic. So now we are going to talk about seismic noise. Mind you, I've talked about seismic processing. You will record I've talked about seismic processing, where I told you that information that is gotten from the waves that are sent to the earth crust, the information are returned via the geophones or the hydrophones, and they are sent from remote location to.
Engineer Joshua, please time up.
Okay, so I've already given them. I've already given their assignment. I believe they were hearing me. So I'll give them the assignment. So I give you, as I said, number one, explain the organic theory of crude formation. Number two, define the following geologic terms: organic matter, reservoir rock, sea rock, trap, and migration route. Thank you very much, and we'll meet you on the platform again by the grace of God next week. Have a nice time.